I share a screen. I want, if you see the blackboard, let me know. Blackboard, whiteboard, sorry, whiteboard. Do you see the whiteboard now?
Yeah, we see it.
Yes. Yes.
Okay, you see? Nice. Everyone saw that? It's the MAC1140 pre-calculus class. Let me explain how many tests, how many homework, how many lab online we have. So, actually, we have 4 tests. Well, this is partial test. It's not final test. So we have final, but a final test is totally optional. Optional. It's only for the students if, for example, fail one test, they want to improve. You see, I have the syllabus here in another computer that I have here. And for example, the test number 1 will be September 24. The test number 2, October 22nd. Test number 3, November 19th. And test number 4, and also the final, the same day. You take December 17th, is the last day. You take test number 4, and the student can need to take the final day. The final is completely optional, no mandatory. Do you understand very well this concept? Let me continue to explain the test. The test normally contain, so we have tests on paper. For example, in one day, the day of the test, I will send to you the test in PDF format. You solve it at home, and you send it back. So you took pictures for each question. Normal test 12 to 16 questions. You solve them one by one. Well, depending the CSB answer or no, you solve in one piece of paper, or we solve in 2 and 1 piece of paper. Depending the size of the question you solve, you took a picture using your smartphone and you send me back a grade at home. Normally, suppose que the test is Tuesday, one day, no? Suppose que October, suppose que September 24. September 24 is, let me see in the calendar. September 24 is, do we send? Yeah, throughout the email. For the same email, I send the link to connect it today. I send for that way. I sent the test on paper. So this September 24 is Thursday. So, okay, you have the entire weekend for doing this. Friday 25, Saturday 26, Sunday 27, Monday 28, and Tuesday 29 is the due date for the test. Okay, so you have time. I suppose it's no big deal. Do you understand this idea? Any question?
Is the 29th correct? The first test?
24, September 24.
Okay.
Do you see the syllabus? Do you have the syllabus or not?
Yeah, I have the syllabus.
Yeah, I'm looking now on the other computer the syllabus. September 24, test number 1.
Okay,
and
thank you.
And you see that before the test, I dedicate 2 sections for make a review. Review. Okay? This is on paper. However, we have another kind of test, yes, online. The lab online is Alex. Are you familiar with the Alex? You never worked with the Alex? It's the first time?
No, I never.
Never. Okay, no problem. I explain now.
Okay.
I explain now. Let me try to explain now. Okay. Alex. Let me share the screen to see Alex. Stop and share. Alex, there you go. Okay. Do you see Alex?
Yeah.
Entonces, to reach that page, you type in www.alex.com, ¿no? Bueno, you have no account. And you click here and they say new student, no?
Yeah.
Of course, I have account. Of course. I log in. This is your class. Your class is Max. The name of your class is MAC1104 2020. Let me see here. Pero full. MAC1140. There you go. Okay. By the way, enroll 4 students.
Okay.
Okay. You open that. In the first moment, you create the account. Of course, I don't want to show you how you create an account, because it's obvious. This is like a program, so you follow in the program the instruction and click next and define your credentials, password, username, whatever, right? And the most important I want to show you is the first, put off the microphone, please, off all microphone. And you click here in assignment. Look, assignments, assignment, and this assignment is waiting for you. Look at that. This is say initial knowledge check. No, skip that. Initial knowledge check, skip that. I don't care. We have 3 homework. Homework number 1 for the test number 1. Homework number 2 for the test number 1. And homework number 3 for the test number 1. We have a test number 1 online, and we have the pre-test. Let me explain it, tell everything. The homework is completely optional. However, I have reward for the student can finish the homework and get in each homework more than 80%. Greater than or equal 80%. You get the score. See, the score is 80% or 90% or 95%, 100%. You have 10 extra points in the total overall grade for the test number 1. The test number 1, you can take in only 2 times, 2 attendance. And of course, when you take both attendance, Alex compute the overall grade of the test for the higher score. Suppose the first time you get 70 and you get 95. When Alex consider get 95. Entonces tú,
yeah, it averages it out.
Exactly. And the pre-test is similar to the test, but you don't need to take it. Only you practice with the pre-test. You can take infinity time. 1 time, 2 times, 3 times. You copy in your notebook. When you are sure you take the test number 1, in the second attendance, you are doing better. Okay.
Got it.
I will sign up for that.
Let me summarize. The big idea. The big idea for this is see share screen. This is a little bit complicated for me, guys. But I try. Look. So you are familiar with the whiteboard, no? Okay.
Yes.
Okay. Alex contain test. Of course, you can see only test 1, no? But you throughout the course you see test 2, 3, and 4. Okay, for any chapter. We have pre-test only for practice. Homework. Homework is optional. Optional. But the reward is 10 extra points. Suppose in the test you get 90 points because you failed 2 questions. Entonces 90 points plus 10, 100. Then homework is this one. Do you understand very well the idea? Do you understand?
Yes.
Okay, let me explain one more thing. Lab online,
Sure.
you have to purchase money. Your money. You can purchase online in the official website for the Alex, or using your financial aid, but you can purchase online in the bookstore of the Homte campus. It's available. If
And
you want,
can you send us a link?
Yes, but I have no here. I need to find, because I received the email with the link. Don't worry. When the class is over, I send the link of the bookstore of the.
Thank you.
Okay, no problem. One more important. But bueno, okay. You can work in the first 2 weeks using the financial aid code. Okay, in the syllable, you can see the code for the lab online, and we have to go. We have the permanent code, get short, and we have the loan, get the financial aid. It's valid for the first 2 weeks. Okay, so my recommendation is as soon as possible, today, you enroll in the lab online. Okay? And what is due?
Okay.
And what is due? And what is due? It's due the same day que es due the test on paper. So we see the test one more precisely. Test number 1, I sent to you September 24. It's due September 29, que es the next class. And this day is due the test on paper and the test online. And of course, the homework. Everything is due. And you forgot test number 1, and we start new thing, test number 2. Any question? Super clear?
Yeah.
Okay. Don't hesitate, guys. Any question, let me know. Or you are shy, typing by...
Actually, I got one more question.
Please.
So you're gonna send the test on paper first before we do the online test?
No. Actually, we can start right now. But not right now because you don't know something, no? Pero, okay. The test online is available now.
Okay.
And you open and you say, wow, I don't understand anything. Okay, but you try little by little. And very important, I forgot to say that. Remember, I am your professor, but I am your friend.
Okay.
I am available 24 hours, 7 days a week. You email me anytime. He asked me specifically, you take a picture. Professor, I don't understand that question. For me, it's easy. I solve it in one piece of paper. I take a picture and I send back to you the solution.
Perfect.
Okay? Of course, homework, pero no test. Okay?
All right.
I know what is the question for the homework, and I know what is the question for the test. Okay. One more thing. Bueno, entonces, si everything is clear, we start doing mathematics, ¿no? ¿O no? Do you see the board or not yet? Do you see the board or no? 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 I need to practice this. Okay, this is the board. Share screen. minimize. Do you see now? Yes or no?
Yes, yes.
Okay, good, good, very good. Okay, the first topic. The first test normally, this class is no big deal. This class is not super hard. This class is, in my opinion, no? The students say it's no big deal, it's no easy, but it's acceptable, no? The test number 1 is easy. The test number 2 is easy also. The test number 3 is no easy. And the test number 4 is no easy. This is the traditional. Okay, teaching do every semester I teaching that class. Okay, that's the first topic we discussing. Jordan, okay, John, okay. No question, guys. Everyone, okay, don't worry. You don't hesitate to ask me throughout the course anytime. Professor, what is do the test? Yeah, I clarify your idea, okay? Let me start for the introduction to polynomial function. Okay. Oh, this is very good. Polynomial. Don't worry. Let me try to the pen. Introduction. To polynomial functions. So the first thing we study in the chapter, in the test 1 is polynomial. Definition first. Definition of the polynomial. Polynomial is a collection of monomial. And what is monomial? Monomial is the algebraic expression like that. Suppose, example, to understand monomial. Suppose 2x to the second power, y to the fourth power. Entonces, the important piece to understand monomial. The first number is the coefficient. Coefficient should be coefficient, no e. In Spanish, yeah, but in English, no. Coefficient is a real number. Real number. So one example of the coefficient is 2, but another example of the coefficient is radical 3 or pi. So it's maybe rational, irrational, or 0.5, or fraction 3/4 coefficients. However, this and this guy is exponent. And the exponent and the definition of the monomial should be whole number. And this is the important thing. Whole number means 0, 1, 2, 3, 4. Okay, it's integer positive number. Okay, for example, to understand this, x to the 3/4. 3/4 is an x exponent, but 3/4 is no whole number. Therefore, this is no monomial. Another example, x to the -2 is negative. The exponent is -2. -2 is no whole number. This expression also is no monomial. No monomial. No monomial. This is clear. Huh? This is super straightforward, right? Now the important thing is the degree. The degree of the monomial and the degree of the polynomial. Let me explain degree. This is important concept we are working frequently. Degree. Suppose this expression. Suppose 3 x to the second power plus 4 x plus 6. It's a polynomial, right? Polynomial. It's a collection of monomial. Monomial 1, monomial 2, monomial 3. The degree of this is 2. Is the exponent. Here, 2. The coefficient obvious is 3, but the degree is the exponent. The degree of this is 1, because this is invisible exponent 1, right? And the degree of this monomial is 0. Degree 0. When you see one number that x is missing, it's because it's x to the 0 power. Because I know that x to the any power of 0 power is already equal. So this is the degree 2 and the first monomial, degree 1 and the second monomial, degree 0 and the last monomial, but the degree of the polynomial is the greater number, is 2. This 2 is this 2. This 2 is this 2. You take the degree of each monomial. This is the degree. Super clear?
I have a question.
Go ahead.
All right, so for the 6x and the 4x, why does the 6x, I mean, the 4x has 1 degree, degree equals 1, and 6x equals, the degree is 0. They're both x.
Okay. The degree of this is 0. The degree of this is 1. 1, not 0, 0. When you have 4 to the x, okay, the exponent is missing, it's because it's 1. And this is degree 1. And degree 1 is equivalent to, say, a linear. Linear. What is this? Noise. Pulling off the microphone. Are you clear, mister? Degree 1, degree 0. Okay, repetition again, another example. Repetition, another example. This is super straightforward. Suppose this. Radical 2, x to the 6th power, plus pi, x to the 5th power, plus 20, x to the 4th power, plus, yeah, I suppose que maybe not necessarily as a sequence, is 40x plus 2000. What is the degree of each monomial? Degree of the first one. What is the degree? 6. What is the degree? 5.
5.
What is the degree?
4.
4. What is the degree of this guy? 1, because the exponent is invisible. 1. And what is the degree of this 2000? 0. Because x is missing, entonces I suppose que es x to the 0. Because I know que any number or expression raised to the 0 power is equal to 1. Yeah. This is equivalent to 1. Now, it's clear? Clear? Degree is clear? Okay, super. Let's go to the most complicated part. Let's go to the graph. How look like the graph of the polynomial function? Polynomial graph. A polynomial is a smooth curve, like that. Wow, smooth curve. Because it's smooth, it's continuous. I want to explain what means continuous. Continuous means that the curve we can draw without lifting the pencil from the paper. So no holes, no corner, no asymptote, no cup. Let me explain what is that. Hole is like that. Suppose a curve, and we have a hole in the middle. This is a hole. The polynomial graph never have a hole. Never. Corner, like that. Never have a corner. Asymptote. Asymptote is something like that. Tuk, asymptote. And you never touch it. Asymptote. This is vertical asymptote. Never. I never have a cup. Cup is something like that. similar to the corner, but a little bit curvy, like that. Now, cut. So in conclusion, the graph that we are doing now of the polynomial function is super nice. It's a smooth curve, okay? A smooth, totally continuous, smooth, totally continuous, and not complicated. Okay?
Okay.
Okay. This is the most important characteristic of the polynomial function. Wow, what the hell? Well, okay. Don't worry. Okay. Let me explain now a behavior. Pay attention. This is not complicated, but it's a little bit confused. And behavior. It's valid, and behavior is valid not only for the polynomial, it's valid for any function. Specifically, I want to study any behavior of the polynomial function. So basically, the polynomial function is formed by that function, x to the n power. This is the power function. Monomial, no? Power function. And depending si m is even number or m is odd number, well, the function is even function or odd function. I want to explain using an example. Suppose y equal x squared. It's a parabola. It's a parabola like that. It's a parabola like that. In this case, it's a parabola. Y equal x to the third power is odd number. Is something like that. And the family, suppose the family of the even exponent look like always like that. And the family of the odd exponent look like always like that. Suppose you have x to the 4th power. It's exactly the same, but a little bit more increasing faster, like that. And a little bit flat in that part. Okay, by the way, that part is in between 1 and negative 1. Suppose now x to the 3rd power is exactly the same, but something like that. This is I'm going to say, what is the end behavior? Professor, one of the end behavior is, in order to determine the end behavior for the one polynomial function, look, let me show you example. Suppose that we have the function like that. F of x equal minus 4 x to the 5th power plus 6 x to the 4th power plus 2x. Hey, microphone off. What is the end behavior? End behavior is when the x approaches to positive infinity or negative infinity. So suppose this is the all real number line. This is positive infinity and this is negative infinity. I want to study what is the behavior and behavior of this polynomial function and this value when the x approaches to positive infinity and when you approach it to negative. It's obvious to say approach to infinity. Infinity represent a huge number positive or a huge number negative. Okay? 10 million or negative 10 million or negative 20 million. Therefore, in order to find the end behavior expression, you ignore this guy and ignore this guy. You take only the monomial que contain the higher exponent, so negative 4 x to the 5th power, because when you plug in infinity here, infinity here, infinity here, the term it have more weight, numerical is greater is this. So that's easy, determine the end behavior because you take the term, the monomial, que contain the higher exponent. Okay? But not always is easy. Sometimes it's a little bit complicated. Let me show you one example, and you try to help me to find the end behavior. Okay, suppose another function I want to call g. G is equal 1 over 4 x parenthesis 2x minus 3 cubic x plus 4 raised to the second power. My question is a polynomial, yes or no? Yes or no? What do you think? Is a polynomial, yes or no? Yes or no? Yes.
No.
No. No. Yes. No. Yes. It is a polynomial.
Yes.
What is the only problem? The only problem is that I write in factory form. That somebody, not me, do the factorization. But okay, if you want, you spend time, maybe 30 minutes, to expand this multiplication, this and this together, and you get a big polynomial, right? But this is not important. This is just a stupid algebra. Now, this is a polynomial when you expand this. Because this polynomial that the professor put in the board is expressed in factory form. Okay, sorry. But my question is, what is the end behavior? What is end behavior? Expression. Que characterize this polynomial. What do you think? Opinion. Come on, I want to hear opinion. Remember the end behavior. End behavior, you think x is a huge number positive or a huge number negative. This is the idea for the end behavior. You're plugging in here a huge number. So what is the end behavior? Well, I suppose that 1/4 stay. And x stay also, no? But here, so you're plugging in as 2x minus 3 cubic. But okay. But so you're plugging in here a huge number. It's obvious that this 3 is completely negligible. Yes or no? Okay, suppose million. I am millionaire. Million times 2 million. Minus $3 is nothing. So this is completely negligible, and this 4 is completely negligible. So my expression look like that. Look, this is 2x cubic and x squared, correct? You delete this, you delete mentally, you delete it according to the end behavior, no? So now let me simplification a little bit. This expression, no? 2 to the cubic power is 8, divided by 4 is 2. And we have 1, 3, and 2. This is 5, 6. Do you see the expression and behavior? This is the answer. The answer in the first was easy. You take only the greatest exponent. In this case, the factor 4 is a little bit more complicated. Do you see or no? Entonces, bueno, okay. Entonces, what is the application? What is the utilization for the end behavior? What idea help me to understand end behavior? One, okay. End behavior help me to understand a little bit how look like my graph. My graph look like, let me see, in this case, 5. You know that the 5 is something like that. Okay, I don't know exactly what happened in the middle, but I know that the end behavior is 5. Remember, when this odd, the polynomial graph will look like that or like that. When it's odd, point. When it's even, look like that. I don't care. This is just end behavior. This is even. Oh, like that. Even. This is even. And this is odd. Okay? You can represent graphic or you can say, well, professor, this is left up, right down. Left up, right down. In this case, is left up, right up. Both is left and right is up. Do you understand the idea? Or I need to explain more clear? Aim behavior application, utilization of the aim behavior. Huh? No Canva. Eraser. I don't know what happened here. Delete. Okay. Okay, don't worry. Let me try to move that direction. Do you understand behavior or no? Okay, so important thing, aim behavior. Another important thing to do the graph, because the objective today is do the graph of polynomial function. Important, super important is y-intercept and x-intercept. What is y-intercept? What is the formula for finding y-intercept? Is the function evaluating 0. And what is the formula for finding x-intercept? Is the function equal to 0. And the real solution of this equation represent the x-intercept. Let's see example. One straightforward example. Very, very easy. Example 1, to understand everything that we study now. The polynomial function is f of x equal x cubic plus x squared minus 9x minus 9. Okay, super. Let me review a little bit and behavior expression and behavior expression. Who help me? What are the end behavior expressions for this polynomial? Please tell me. Using the chat. Hello, are you there? SQ, very well. End behavior expression is easy because I know factory form. You take this the monomial que contain the higher exponent. Super. Entonces, si you want to represent graphically, this look like that. I don't know exactly what happened in the middle, but I know that my graphic look like that. It's right up and left down. Super. And left down. Okay, now let's go to the new part, que es compute the y-intercept. Y-intercept is super easy because you evaluate the function as 0. And when you evaluate the function as 0, the end expression is which is the most. Hey, noise. Mister, activate the microphone and repeat the question. What do you ask me about?
That's crazy. I really stayed at Juggle that long. I'm going to give out a manager position.
Oh, noise. Just noise. Entonces, using the chat. Bueno, I continue. Y-intercept is super easy. You evaluate in 0. When you evaluate in 0, plugging in 0, 0, 0, 0, the answer is negative 9. It's obvious, right? The answer is obvious, it's negative 9. So to find, and the polynomial function, the y-intercept is obvious, is the term that do not contain x. The term when the x is missing. So the point is the point 0, negative 9. Because x is 0 and y value is negative 9. And x-intercept always is a little bit more complicated. You try to solve it this equation. Suppose the equation is x cubic plus x squared minus 9x minus 9 equal to 0. So you put equal to 0 the y value, and you manipulate algebraically this expression in order to isolate. As you are doing factorization, factoring by grouping. For example, this couple, the great common factor is x squared. And this couple, the great common factor is obvious que es negative 9. I can see, wow, x plus 1 is common factor. Stay in the second parenthesis, x squared minus 9. I can see then this is the difference of a square. So we continue factorization. So you have to complete a square. Difference of squares. Entonces es x plus 1. Open two parentheses. Square root this is x. Square root 9 is 3 plus or minus. And the solution, when you apply the zero factor property, each factor is 0, and the solution x plus 1 equal to 0 is obvious that the solution is negative 1. X plus 3 equal to 0, the solution is negative 3. And x minus 3 equal to 0, the solution is x equal positive 3. No parentheses, guys. Now, the set of the x in a set are negative 1, 0, comma, negative 3, 0, comma, 3, positive 3, 0. Now we are ready now to do a rough sketch of this polynomial. This is the end behavior, okay, look like that. However, we determine a negative 9, que I suppose que here, negative 9. So this point is the point 0, negative 9. Okay, our polynomial passing through that point. However, we have approximately. Okay, let me try to do more elegant here. Okay, this is my rectangular coordinate system. I know that the end behavior is like that. We discover that here in 1, 2, 3, negative 3, 0, we have x in a set. And likewise, 1, 2, 3, 0 is another x in a set. And negative 1, que is here. Negative 1, 0 is it. And we discover also that in 0, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 here, we have 0, negative 9 is y in a set. Let me use another color. Is my polynomial graph look like that. Got it? It's clear. Yeah. Okay, but I have surprise for you now. Surprise for you. We never. Remember, we are living in the United States of America. We are living in the 21st century, and we have a lot of software to do graphic of any function. And we working in pre-calculus. We working with the two important software, super important software. The first one that we study now is called Desmos. Desmos. Do you see before Desmos or never you see before? Somebody saw Desmos before or never? Yes, Jamil say yes. Another student can saw Desmos at least one time in your life. Okay, money. Okay, let me switch into Desmos. Okay, okay, good. Let me switch into Desmos to see Desmos, and you see surprise. So, and the test. Okay, and the test. You are doing the graph in the paper, no? Well, yeah, you are doing the paper because you want to show me, no? You take a picture and send me back. However, in the real life, we are doing here. In the look, Desmos is super easy. Here, Desmos. You look at the Desmos. You go to the look at the address www.desmos.com, So I recommend you that you create your own account. Look, this account is Jorge, que is my name, right? It's super easy because when you try to create account, the only information that you need to provide is the one email address, and you define one password, and that's it. And you have your special account in Desmos, and anything that you are doing in Desmos, you save, okay? And you can use it in the future. So suppose example number one that we are doing today, example number one, look at that. Example number one, look, is that function que is x cubed plus x squared, and the graph look like that. Look at that. But let me try to wait a second, projector mode to see much better, more elegant. Okay, you see clear. I put a graph. If you want, you put the points. Look at the point. The most important point is 1, 2, 3 x in a set and 1 y in a set. I plot that using the color that you want. You change the color if you want. For example, I want to change no red. I want to change to black. You press here. You select here the color that you prefer, and the point now is black. Okay, this is the thing that we are doing in the test. Anytime, no on paper. You are doing it in your own, and it's easy because it's totally online. You don't need to download in your computer or device. You can use it in your laptop or in your smartphone, because we have Desmos and apply in your smartphone. Do you like? Do you like? I love you. We are the best in Miami-Dade College, coño. Okay, let me try to explain one theoretical thing. I come back to the board. We study in detail, you know, the x in a set and the y in a set, right? But I want to explain something. Look, let me show you. Suppose, in this case, I don't want to do the graph. I want to explain the theoretical idea only, right? Okay, look, suppose this polynomial. This polynomial is f of x, example 2. No, example 2, example 1.5. Because I want to explain only one theoretical part, not do the graph of this. Suppose a polynomial like that, f of x equal x squared, parenthesis, x minus 2 cubic, and x plus 4, 7 power. Entonces, what is the end behavior expression? Be careful because this is factory form. The end behavior expression is x squared stays the same, no? You delete mentally these two and delete mentally this 4. Entonces, x to the cubic power, and this is x to the 7 power, no? And this is 10, 12. Entonces, si es 12, que es even, the end behavior look like that. Y es positive. Even and positive. Because it's even negative, it's down. Pero even, positive. This is the end behavior that give me approximation. How it look like my graph. 7, 3, 12. Okay, good. Now, important thing is, let me see, 2, 3, 7, no? Okay. The important thing is how, or at what point the graph touch or cross. So actually, we have in my graph, we have here one factor is in 0. At this point is 0. We have one second factor is 2. 1, 2. It's another 0. At x equals 0 is the x in a set, no? X equal 2 is another x in a set. And at x equal Negative 4 is another 0 que es 1, 2, 3, and 4 here. Negative 4. 0 and positive. Positive 2. It's interesting because when you see in the factory form negative, it's because in the graph is totally opposite sign. And you see positive 4, negative 4. And the graph look like that. Look like that. Entonces es en 4 cross. How do you know que cross? Because when the exponent is odd number, cross. When the exponent is even, touch. So touch, even. Cross, odd. Now 3. 3 is also cross, no? Also and 2 cross here. Cross, but here touch. I suppose I don't know exactly what happened, but touch. Touch. Okay? Okay, what is the idea? This is cross, and this is touch. Maybe like that, or maybe like that. This situation happens when the exponent is even. This situation happens when the exponent is odd. Depending is in this direction or in this direction. So basically, if the exponent is odd multiplicity, this is the name of this. And when the exponent is odd multiplicity, the graph crosses the x-axis at this point. When the multiplicity is even, depending of course the exponent, the graph touches the x. Okay? Let me try to see more easy example. Okay, we are doing by hand and we are doing in Desmos to make sure. This is actually the example 2. This is the example 2. Actually, it's example 2. You put the polynomial like that. X to the 4th power minus 4x to the 2nd power. Question number 1. What is the degree of this polynomial? What is the degree of this polynomial? What is the degree of this polynomial?
4.
4. Very well. What is the good. Very well. What is the end behavior expression? Help me. What is the end behavior expression of this polynomial? What is the end behavior expression of this polynomial? Nobody. X to the 6, x to the 6 or to the 4? No, x to the 6, to the 4. Sir, you analyze monomial by monomial, degree 2, degree 4, and you take the higher, the bigger. Okay? No. Es, okay, maybe you're confused si es multiplication. Suppose que es x to the 4 and another variable, suppose y to the 2nd, entonces degree is 6. But it's not the case because we are using only one variable, que es x. Okay? Okay? Now, determine the intercept. The intercept, in order to find the y-intercept, you evaluate the function as 0. And you evaluate the function as 0 is 0 to the 4th power minus 4 times 0 to the 2nd power. It's all because 0, and the point 0, 0 belong to the graph. In this case, 0, 0 is both. It's x-intercept and y-intercept. Okay. Now, let's go to the x-intercept. The formula is f of x equal to 0. In other words, it's x to the 4th power minus 4x to the 2nd power equal to 0. And you solve this equation. Is there common factor? Yes, x squared is common factor. X squared minus 4 equal to 0. And this is the difference of square again. X plus 2, x minus 2 equal to 0. Entonces, 1 by 1, each factor is x squared equal to 0. It's obvious the solution is 0. In this case, the multiplicity is 2 because square. So actually, it's like 0, 0, 2, 0. and the other is -2, multiplicity 1, and x equal positive 2, multiplicity 1. Okay? Now, this is the moment to do the graph by hand and check it out in Desmos, right? By hand is, let me see. This is the graph, XY. We have a point. The first point is 0,0 at the origin, 0,0. The second point is 1, 2, 1, 2. So I forgot the aim behavior or no? Well, the aim behavior, what the aim behavior is even, no? The aim behavior was monomial expression was x to the 4th power, no? And the x to the 4th power look like that. Chun, 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 chun. It's right up, left up. Entonces the point is 1 point here, 1 point here. Entonces en this point, the multiplicity is 1, que es odd. Therefore, the graph crosses. Here also crosses. But in 0, no, because it's 2 the multiplicity. Therefore, the graph touch. Right. I did roughly, I suppose that this is perfect symmetric, right? So that part is exactly the same like that because it's even function. And remember, even function in Euler algebra is symmetric with respect to the y-axis. Well, let me verify my analysis using this one. Let me go back to Desmos. Go. Got it. Do you see Desmos again? But obviously, this is the example 1, no? Let me see example 2, no? Look at that, example 2. You make a zoom to see more clear. This is the polynomial. If you want, you put y here, or no, y equal. I like to put y. And this is the graph. Any question? What part you don't understand? Super. We are the best in Miami-Dade College. Oh no. Or is it too hard? Too easy or too hard? Too. Okay, you want to say sum up. Two sum up. Okay, good. Let me explain another theoretical part. I come back to the board. Board now. Share. You see the board? Oh no, no. No? Now yes, the board. Do you see or no?
Yeah.
Okay. 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 Let me explain turning point. This is another important idea. Turning point. Normally, the polynomial graph look like that, turning point. Suppose 3 different cases. Suppose degree 2. Well, degree 2 is x to the 2nd power, no? Suppose it's a parabola. Well, we have more thing here. Not necessarily it's the classical parabola, because the vertex is in the origin. No. It's a parabola. But the turning point, TP, is 1. Because we have this point is a turning point. So it's the point in which the curve decreasing and stop and after increasing. So decreasing. This is turning point. See, degree is 2, we have one turning point. Suppose degree 3, normally the graph of the degree 3, so IQB plus something, no? Look like that. We have two turning points. One here, one here. Turning point equal to. Suppose n equal 4, x to the 4 power plus something. Look like that. Suppose. This is the n behavior. This is the n behavior. Look at that. This is the n behavior. Is right up, left up, right up, left down, right up, left up. And the turning point are, how many turning points? We have 3, no? 1, 2, and 3. So what is the conclusion? The conclusion is no simple. It's not easy. Is see you have a polynomial and the degree is equal m, the amount of the turning point is at most n minus 1. Look, degree 2, 2 minus 1 is 1. Degree 3, 3 minus 1 is 2. Degree 4, 4 minus 1 is 3. Pero the word at most indicate que es greater than or equal. Okay? Why? Because sometimes happen, for example, the classical example of the function y equal x cubed is degree 3, n is 3. However, when you are doing the graph of this, look like that. And the turning point is 0. We have no turning point. Okay, entonces at most indicate que maybe es at most indicate que maybe es turning point 0, turning point 1, turning point 2, and that's it. So in the degree 3 is impossible. Turning point 3. No, at most. Do you understand the idea for the turning point? Super. Okay. Let me spend the last moment. It's okay, guys. You understand very well or no? Too much information for good, very good. A little bit, no, good. Okay, remember, I don't want, no, professor, a little bit, no, a little bit is C or D. You want to get A? Is no, or 90, 91, 92. 90. Okay, let me refresh your memory about what's the problem? The examples that we are doing so far are too easy. And to find or for finding the excellent set, the only way that we are using is factorization. However, factorization is weak. It's very, very weak method. And we need to study another strong way to find the zero of the polynomial. In other words, zero means the excellent set, the real excellent set, using another mathematical procedure. And this is synthetic division. Do you remember synthetic division you see before in your life? Synthetic division or never you see in your life? Yeah, you see. Okay. Don't worry. I try to refresh your memory. Okay, synthetic division. Let me try to explain first of all quickly because we have only 10 minutes, no? Long division and synthetic division. Long division first. Long division, and after synthetic division. Okay, I want to do in both ways. I explain the limitation in both cases. Suppose this elementary example. Suppose I need to divide 2x squared plus 3x minus 14 divided by x minus 2. And we are doing it both ways, using long division first and use synthetic division. And you see advantage and disadvantage. Entonces, long division, you create the typical format for the long division, no? Is you copy this is divisor, this is dividend. Okay, the dividend you copy inside the box, 2x squared plus 3x minus 14. And outside, you copy the divisor, no? Okay. And you start the division. You copy here one expression that multiplied by the first look like equal to this. Obviously, it's 2x. Because 2x times x, okay, this multiply this times this. Okay? 2x times x is 2x squared. And this times this is obvious que es negative 4, no? Negative 4x. By subtracting, you change the sign. It's a typical procedure for the division, no? When you divide in arithmetic, in elementary school, you divide 5 divided by 2. You say 2 times 2 is 4, subtracting 1. Remainder 1, answer is 2. Okay, it's a quotient. And this is a remainder. Yes or no? You remember that or no? Exactly the same we are doing in algebra. So this is cancel. Okay, good. This is 7. And bring down the next guy. How do you know okay, we have to continue the long division or you stop? Stop or continue?
Continue.
Continue. What is the clue that give me information? Okay, I need to continue.
The 7x minus 14.
What happened with this guy? What is the degree of this polynomial? What is the degree of this 7x minus 14? What is the degree of this?
1.
1. And what is the degree of the divisor? What is the degree? What is the degree x minus 2? Also 1, no? Entonces we stop when the degree of the remainder is smaller than degree of the divisor. So you stop, when the degree is 0 here. Entonces we continue. This is plus 7, no? 7 times x, 7x. 7 times 2 is negative 14. By subtracting, change the sign. In this case, by coincidence, remainder 0, and the answer of this division is just this. Any question? Let's do it now in synthetic division. Synthetic division is fantastic, but synthetic division has limitation. What is the limitation for the synthetic division? Well, first of all, you only apply when the divisor is degree 1. If the divisor is the degree no 1, we cannot apply synthetic division, but in the majority of the case, this situation happens. So you are doing similar. You open the same symbol and you copy the dividend expression, but without variable, you copy 2, 3, and negative 14. Okay? And you copy here that expression, but only using the number and opposite sign. Wow, opposite sign. See, in the long division, you see minus 2. In the synthetic division, you put positive 2. Opposite. This is minus, this is positive. This is plus, this is negative. Why? Because you never hear, here systematic, I need to change the sign one time, change the sign. No, I change the sign one time. Here, and bring down to 2 times 2 is 4. 4 and 3 is 7. 7 times 2 is 14. Subtraction, 0 remainder. So on the 0 remainder, this is exactly the same of this. And the answer is, this is x to the 0, x to the 1. The answer is 2x plus 7. Exactly the same. Wow, I like so much. I like so much. Synthetic division. Do you remember or you don't remember? But what is the problem? What is the complicated situation maybe we have in synthetic division? No? Okay. I never learned this. Wow. What happened in high school, guys? Okay, no, but don't worry because we practice every day synthetic division. We practice every day. This is the most interesting and you are old. Okay. But how old, mister? No, no problem, no problem. The age is not important. 59. Good, you are young. Okay, let's practice a little bit. Scientific division. Let me try to find one nice example. Suppose this example. X cubic minus 6x squared plus 11x minus 6 divided by x minus 1. Okay, polynomial degree 3 in the top, polynomial degree 1 in the bottom. Entonces, what's the answer? Well, the answer, when you perform that division, you obtain 3 minus 1 degree 2. And remaining, I have no idea. But okay, don't worry. I try to do, this is the interesting because you apply 3 times scientific division. I copy 1, negative 6, 11, and negative 6. This is the coefficients here. 1 invisible, negative 6, 11 positive, and negative 6. And you divide by 1, no? Remember, opposite sign. See, in the binomial, you see minus 1, so you put here positive 1. Bring down 1 directly, not doing any operation. And multiplication. 1 times 1 is 5. 1 times 1, sorry, is 1. And now subtraction is negative 5. And multiplication, negative 5 times 1. So the action, you bring down this one directly. And you multiplication, this and this. And you copy that multiplication here. And you combine like term, negative 6 and 1, negative 5. And multiplication, this and this is negative 5. And this is 6. And multiplication, this and this is positive 6, and the remainder is 0. That means, when the remainder is 0, that means okay, x minus 1 is the factor of this polynomial, because when you perform the division, you get 0 remainder. 0 remainder. It's important, this idea. Let me try to continue perform more scientific division, because I want to factorization complete this. Wow, what the hell? Okay, don't worry. I copy. I continue. Let me use another color. Let me use it blue color. Suppose I want to continue perform another scientific division using, for example, 2. I did 1 using 2. 1, okay. Bring down 1. Multiplication 1 times 2 is 2. Negative 5 plus 2 is negative 3. And negative 3 times 2 is negative 6. And again, 0 remains. That means that the factor x minus 2 is also factor of this polynomial. And finally, this is the answer of the division, okay, is x to the 0, x to the 1. Therefore, I can see no more scientific division anymore. Is the factor x minus 3 is also factor. But in super easy way, you are doing the factorization of this polynomial. Original was, remember, was x cubic minus 6x squared plus 11x minus 6, and the factorization was x minus 1, x minus 3, minus 2, and x minus 3. You can see it doesn't matter. The order is not important because of multiplication. And in the multiplication, the order is not important. So we are doing the factorization without the rule of the factorization that we studied in elementary algebra. Guys, too much for one day. We continue practice scientific division on another more complicated topic. Do you like that class? You feel good? Okay. Giovanni is good. Everything is good. You like? Okay. Guys, well, I love you so much. So remember, 205, 30. We continue that part. Okay?
Professor.
Take care. You want to say something?
Yeah.
Come on.
Do you calculus and analytic geometry?
No, I don't understand.
Do you teach calculus and analytic geometry?
No. I teach in calculus 1 and 3.
Okay.
Analytic geometry. This is not the name of the subject.
No. It's because in my next calculus class, I need calculus and analytic geometry.
Poca sangre. To take calculus 1, you need to pass this class.
Correct.
Trigonometric. Okay.
So it's because the next class I need to take, because I'm an architectural engineer, I have to take calculus and analytic geometry. That's the name of the class. So I was wondering if you taught it.
Let me try to explain again. This class is MAC1140, correct?
Correct.
You have to take another case, MAC1114.
Which I did.
Trigonometric. So when you take both, you are ready to take calculus 1, que es MAC2311. Okay, and after sequentially, calculus 2, MAC23. Okay, clear now?